two different types of acceleration acceleration in uniform circular motion. If we see, in case of uniform circular motion, there are two types of accelerations exist. Which are those? Okay, first let us try to understand what is the meaning of circular motion. Circular motion indicates that anything moving in a circular path. Here if you take, it may be electron moving around the nucleus, or whatever, any object which is moving in a circular path. Circular path means path of the electron or path of that particle is a circumference of the circle. So here there is a radius r, and velocity in case of a circular motion always along the tangent. Velocity is a vector quantity, and here radius. Now there are two types of acceleration possessed by the particle when it is moving in a circular path. Is one, centripetal acceleration. Centripetal acceleration. What is centripetal acceleration? The centripetal means towards the center, or center seeking, center loving. Centripetal means center loving. See here what we are getting. Centripetal acceleration is always towards the center, and normally it is denoted by the letters AC. So here what you can get now, AC is given by the expression V square by R. What is V? V is linear velocity of a particle moving in circular path. Then R is radius. R is radius of the circular path. Now you can immediately write here acceleration, centripetal acceleration towards the center. So this is AC, along the radius towards the center. And one more type of acceleration exists. It is here tangential acceleration. Tangential acceleration. It is, from the name itself you can understand, tangential acceleration is along the tangent, along the velocity. Radius is towards the center, centripetal is acceleration is along the radius, and velocity is along the tangent, tangential acceleration along the tangent. And it is denoted by AT, and very simple formula, what we know that formula is nothing but AT is equal to V square. AT is nothing but R into alpha. What is alpha here? Alpha is nothing but angular acceleration. angular acceleration is the alpha. Angular acceleration. Now, what we are getting that actually angular acceleration is alpha. Okay. Now there are, you know that. Now if we write here what you are getting here, centripetal acceleration along the radius and tangential acceleration along the tangent. Now you know that in case of a circle, centripetal acceleration is along the radius, tangential acceleration is along the velocity, and you know that in case of circular motion, velocity is perpendicular to r. Since velocity along the tangent and radius perpendicular to each other, therefore centripetal tangential acceleration is perpendicular to centripetal acceleration. This is one of the very important point we should remember. Now, if you construct a parallelogram like that, then net acceleration is along the tangent. Net acceleration is along the diagonal of the parallelogram according to parallelogram law of vector addition. According to parallelogram law of vector addition. You know that acceleration at any point on the circular path. Acceleration, if you can take the point here, or point here, or point here, or point here, or point where, anywhere. Acceleration net acceleration at any point on the circular path, that is A net is given by square root of a t square plus ac square plus 2at ac cos theta. Parallelogram law of vector addition, you know that if there are two vectors, vector A and vector B are two vectors, then their resultant is given by vector R is given by, or magnitude of vector R is given by square root of a square plus b square plus 2ab cos theta. Okay, 2ab cos theta, what you are getting. Then similar way, you know that now here theta is 90 degrees. Since tangential acceleration is perpendicular to centripetal acceleration, then acceleration at any point of a particle on the circular path is given by, if you see here vector at, here vector ac, then their resultant is always, construct parallelogram, diagonal gives the value of a net. So this is the point what you should remember. Now you can easily understand what you are getting actually in this case. See here, since theta is 90 degree, net acceleration is always given by square of tangential acceleration plus square of centripetal acceleration. This is one of the very important shortcut formula to find out net acceleration of a particle at any point on the circular path. Particle may be here at any point on the circular path. So these are the two different types of acceleration you are getting. So this is one of the very, very important formula for competitive exam. Net acceleration at any point on the circular path of a particle is given by a net is equal to square root of at square plus ac square.